Alright students, today we are starting a new chapter on polygons, and you will notice that in this first section, 8.1, most of the information you are very familiar with from middle school. We are just going to take the middle school concepts and just expand on them a little. First, let's start with vocabulary. Polygon, you may remember, is a closed plane figure. That just means that it is a shape that is flat. And this figure is formed using segments. Formed by line segments. Okay, so I'm going to give you examples and non-examples. Examples over here, non-examples over here of polygons. Okay, one polygon that you're very familiar with is a three-sided polygon. Here's another one. This one has 5 sides. Here's a 4-sided polygon. And then here's another one. This is 1, 2, 3, 4, 5, and 6. You'll see both concave and concave over here because they cave in, and convex over here because they all poke out. Alright, so non-examples. Any curved shapes, any shapes that have any curves at all are not a polygon. Here's another one. They have 2 sides, but see it has this curved side also? That's not a polygon. If any of the sides crisscross, like this, that's not a polygon. It's not a polygon as a whole shape, but this actually is 2 polygons, 2 of those joining together at one of the vertices. So that's 2 polygons, but it's not a single polygon. And then where it says a closed plane figure, that means that it can't be open. So here's an example of one that's open. Okay, so it doesn't actually close. Alright, so here, sides are non-collinear. All sides are non-collinear. So you can't call this a side, this a side and this a side, because these would form one line. So this one doesn't work because of this. All sides are non-collinear. So this would fail because of this. And 2, each side intersects at 2 endpoints. Only 2 endpoints. Okay, so here, this side right here intersects this side at that endpoint, and it intersects this side at that endpoint. But here, if you see this side right here intersects here, here, and here. So that's why this is not a polygon. Concave means that it caves in. Alright, so it has a point in the interior of the polygon. Okay, that's what it means. It has a point on the inside of the polygon. So here, if we're going to make a polygon out of this, this area in here would be the inside. So the next point here, this point right here is considered the inside of the polygon, so it caves in. And if it were raining and this was an actual shape and we could collect water, the water would pool in here. Okay, so that's concave. Here's another one. Very popular shape, especially in our state. And that's concave because it caves in. Okay? The next one is convex. Convex means that it doesn't have any points on the inside of the polygon. So no points or vertices in the interior of the polygon. Alright, so everything that pokes out like these two over here. Here's another example. This is a five-sided figure as well, just like this one was five-sided figure, but this one is concave because it caves in, and this one is convex because it does not cave in. And then here's another one. 1, 2, 3, 4, 5, 6. There's a six-sided convex polygon. Regular polygon means that it is convex. It's a convex polygon with all sides and angles congruent. And I'm going to write the congruent symbol. That's the congruent symbol. That means that all the side measures are equal and all the angle measures are equal. So I'm going to draw a triangle. And this would be an equilateral triangle because all the sides are equal. And it's also equal angular because all the angles are equal. Another very popular shape that you know is a square. Okay, all the sides are the same and all the angles are the same. They're all 90 degrees, but I'm just going to draw them as hash marks so that, not hash marks, as arc marks so that you can see that they all equal each other. Interior angle. Interior angle is the angle located inside the polygon. Okay, so if I draw a pentagon, five-sided shape, this angle right here would be an interior angle. An exterior angle is an angle that we don't normally see, but we have to actually draw it. An angle formed by extending one side of a polygon. Okay, so I'm going to take the same shape that I just had here, this pentagon, alright, now if I take this side right here and I extend it, then this angle from this side that I extended back towards the polygon, this side, this right here, this angle, that's an exterior angle. Diagonal. A diagonal is a segment that connects two non-consecutive vertices. That means two vertices that are not next to each other. So, again, I'm going to take the same pentagon, okay, so if I start here with this, identify this one as my vertice. If I'm going to connect to another vertex, this would be considered a consecutive. So I'm not going to connect here, but I would draw a line this way. I'm going to draw a dotted line. This dotted line, that is a diagonal. You could draw another one here, but you can't draw one here because that would be the side of the actual polygon. Okay, now, naming of the polygons. This is something that you probably are very familiar with. A three-sided polygon is called a triangle. A four-sided is a quadrilateral. A five-sided is a pentagon. Six-sided is a hexagon. A seven-side is a heptagon. And you're used to, in middle school, probably calling this a septagon, but in high school and college, we call it a heptagon. Octagon for 8. Nonagon for 9. 10 is decagon, like decade, decagon, D-E-C-A. 11, that's going to be like 1 plus 10. Un, like uno, for un in their different languages, plus deca, gon, un decagon. That's going to be like another language like do, a do, for 2. So do, deca, so 2 plus 10, gon. And then after that, they don't have, some of them have special names, but we are not going to learn them. We're just going to learn these. And after that, we call it 13 gon, 14 gon, 15 gon. So we are just going to call this the n-gon, the number of sides that it has, gon. Okay, in this next column, it says number of triangles that you can draw. Okay, so I'm going to flip my paper over on the back, and I'm going to start with a triangle. I start with a triangle, and I ask myself, how many diagonals can I draw? Now remember, it has to be non-consecutive, that you're connecting this vertex here with a non-consecutive vertice. So here, vertex connected to vertex, that's a side. The only other one that you can connect to is this one, and that's a side. So there are no diagonals. So the only triangle that you have is this one triangle. It's the one triangle that exists. Okay, so now let's draw a quadrilateral. 4 sides. I'm just going to draw that shape, which is not really a square, not really a rectangle, just a quadrilateral. Okay, so if this is my vertex that I'm focusing on, if I connect it over here, that's a side, but I can connect it over here, and that makes one diagonal, and if I can connect it over here, that would be a side. So how many triangles do you see? It can make 2 triangles. So this one has 2 triangles. All right, one more, and then you'll see the pattern. Here's my pentagon. Kind of looks like a house. All right, so here's my vertex, and I'm just going to pick this one. That's a side. There's one diagonal. There's 2 diagonals, and that's a side. So how many triangles do you see? I see 1 here, I see 2 here, and I see 3 here. So that makes 3. And you should start to see the pattern. 1, 2, 3. The next one's going to be 4, 5, 6, 7, 8, 9, and 10. Okay, so how many numbers away are there? What's the difference between these two numbers? You should start to see that it has a difference of 2. So to find the next one, or all the others, for all the 13 gone, 26 gone, 100 gone, it's going to just be the number of sides minus 2, because it's a difference of 2. Okay, the other thing that we're going to learn is how to find the sum of the interior angles. So interior angle sum. Okay, if I look over here, you already know the first one. This one is this angle plus this angle plus 6. These are the interior angles. That one plus that one plus that one equals 180. Okay, so flipping my paper back over. So the interior angle sum of a triangle is 180. All the angles inside the triangle add up to be 180 degrees. Now, for the quadrilateral, what you do is you say, well, there's a triangle and it has 180 degrees, and here's another triangle and it's 180 degrees. So 2 triangles times 180 degrees equals 360 degrees. So this one should be 360 degrees. Okay, now notice, that's why I asked for a number of triangles, because 1 triangle times 180 is 180. 2 triangles times 180 is 360. So the next one is just going to be 3 times 180, or just add 180 down. So 360 plus 180 is 540. 540 plus 180, that's 720. Plus 180, because each time I'm adding a triangle, so I'm adding 180 each time. So this one's going to be 900. And then the next one is going to be 1080. Then the next one is going to be 1260. 1440. 1620. And then 1800. Okay. Now, I took the number of triangles that I had and I multiplied by 180. So here's the number of triangles. So that's going to be n minus 2 times 180. And that's how you find the sum of all the interior angles of any polygon, no matter what it is. Okay, exterior. Now, exterior may surprise you, but let's just flip it over and look. We're going to look at the triangle, the quadrilateral, and the pentagon, and then you'll see the pattern. Okay, so here, I'm going to take a color, and I'm going to draw, this is my side, I'm going to extend this side. So here's one exterior angle. Now I'm going to take this side, extend it out, draw it back to the triangle, there, extend it out, there's my angle. Okay, so if I start here, and I go from here to here, and then from here to here, and then from here to here, what did I just do? Look what I'm doing with my pencil. I'm making a circle, and a circle is 360 degrees. So when I walk the perimeter of this triangular building, I am walking in a circle. So I'm circling the building, so that's 360 degrees. Okay, so this one is 360 degrees. So you think since the quadrilateral has more sides, that it would have more degrees. So let's take a look. Extend this side out, draw it back. Extend this side out, draw it back. Extend this side out, draw it back. And extend this side out and draw it back. Okay, so I'm going to start down here, and I'm going to walk the outside of the building. Walk around this way, and then here, and then here, and then here. So I've still circled the building, and when you make a circle, a full circle is 360. Okay, so this one is 360 degrees. Let's do one more. Alright, so here's my pentagon. I'm going to extend it this way, draw it back, extend it this way, draw it back, extend it out, draw it back, extend it out, draw back, extend out, draw back. Okay, so I'm going to start over here. I'm going to walk around, walk around, walk around, walk around, walk around. Again, what have I done? I have walked around the entire building. I've circled the building. So that's 360 degrees. So does it matter how many sides it has? Absolutely not. All of them are going to be 360 degrees. When you walk around the outside, you circle the outside. So all of the angles on the outside equal 360 degrees when you add them together. So here, this is just 360, no matter what shape it is. Okay, we're done with the first page. Second page. Okay, so here's the geometry rules. The interior angle sum theorem. It only works for convex, not the ones that cave in, just convex, just like these. Okay, to find the sum, it's going to equal the number of triangles, n minus 2, that's how we find the number of triangles, times 180 degrees. And remember, n stands for the number of sides. Okay, so let's pretend, this is an awful drawing, but let's pretend that this is a regular polygon. And since this has 5 sides, we would call it a regular pentagon. That just means all the sides and angles are equal. Okay, so this is a regular polygon. Okay, well, first of all, let's find the sum of the interior angles, all of them added together. Okay, well, there's 5 sides. So what that means is I'm going to take 5 minus 2, and I'm going to multiply that by 180 degrees. Well, 5 minus 2 is 3. So 3 times 180 is 540, or I could have looked on the other side because I already did this. So 540. And now what I want you to do is extend this. This is for all the angles added together. This is the sum. That's for each one of these little angles added together, all of them. But let's find out how much one of them are worth. Okay, since all of them are the same, and there's 5 of them, if I want to know what one of them is equal, this is number 2, we are going to take the sum, 540, all of them added together, and we're going to divide by however many there are. 1, 2, 3, 4, 5. So there's 5 of them. And so that means that when I plug this into my calculator, 540 divided by 5 is 108 degrees. And that means that each angle, this is all of them, this is for one of them. So this is 108, this is 108, this is 108, this is 108, and this is 108. And when you add all of them up, it's 540 total. Alright, exterior. Convex, remember it only works for convex, not concave. The sum is equal to 360 degrees. no matter what shape it is. Okay, so remember, extend it out, draw back. Extend out, draw back. Extend out, draw back. Extend out, draw back. Extend out, draw back. And you have to go in the same circular motion. So you either go clockwise or you go counterclockwise when you draw it. Remember, this is a regular polygon, so all of these sides are the same, and all of these interior angles are congruent. Okay, so since we know that the sum of the outside is 360, if I want to know what one angle is worth, I would take 360 and I would divide it by however many I have. 1, 2, 3, 4, 5. Divide by 5 equals, and when you put that in your calculator, that equals 72 degrees. So that means each one of these is 72 degrees. When you add them up, 72, 72, 72, 72, 72, they all add up to be 360 degrees. Okay, let's do some examples. Find the sum of the measures of the interior angles of each polygon. Okay, interior angles, we're going to use this up here. Tengon, that's a decagon. So a tengon or a decagon, that means I'm going to take 10 minus 2, and I'm going to multiply that by 180 degrees. So that means that I have 8 times 180. So that's going to be 1,440 degrees. I want you to do the rest of these on your own and bring them to class with you. And I want you to show your work just like this. If you leave them blank, that means that you'll have points taken off of your homework. All right, next. Okay, just like up here, if you look up here, this says the measure of one exterior angle of a regular polygon is given. Find the number of sides. So we're going to work backwards. So this is given. We know this. This is what we're looking for, the number of sides. So let's write that down. Let's take a look at what we have up here. Okay, to get the measure of one exterior angle, we take 360 degrees. We divide it by the number of sides, or the number of angles that we have, number of sides, equals the measure of one exterior angle. Okay, so that's the information that we need right there to do all of these down here. Okay, so here we know that we take 360, we're going to divide it by the number of sides, which is what we're looking for, and it's going to equal 30. Now think of this is a division problem, but we can also write it as a fraction. So I'm going to write 360 over n equals 30. Now 30 is a whole number, and when you have a whole number, you can always write it over 1. So I'm going to put 30 over 1. And now it looks like a proportion. And now you know what to do with it. You just cross multiply. That's going to be 30n equals 360. Divide by 30. Divide by 30. I get n equals, goes in, that's going to be 12. So that's a 12-sided figure, which is a dodecagon. So it says, find the number of sides of the polygon, and we did. We're done. You're going to do the next 3 on your own, and you're going to bring them into class. Make sure you show your work for credit. If you don't do them, then you'll lose points. All right, last page. Okay, so up at the top, I just want to review a little bit from the other side so we don't have to look back. The measure of one exterior angle is going to equal 360 divided by the number of sides of the polygon, because the number of sides of the polygon is going to match the number of angles. right? And then the measure of one interior is going to equal the sum. Remember the sum? That's n minus 2 times 180. So there's your sum. And you take that and you divide it by n. Okay, and that's how you do the problem. Alright, so I'm going to do this one for you. I have an 18 gone. So to get one exterior, that's going to be 360 divided by 18. 360 divided by 18 is 20 degrees. Now, one interior, before I can do this, I have to know what the sum is. Remember, this is the sum. So I have to do 18 minus 2 times 180. And then when I figure that out, I have to divide it by 18. Okay, so 18 minus 2 is 16. 16 times 180 divided by 18. 16 times 180, when you plug that into your calculator, is going to equal 2,880 divided by 18. Now when you plug that into your calculator, you get 160 degrees. You're going to do number 10 all by yourself and bring it into class. Make sure you find each one and show work, just like I did over here. Okay, state the number of sides for each polygon. Okay, well, here, quadrilateral. Quadrilateral has 4 sides. 83 gone, the number there tells you how many sides, that's 83. Decagon, deca means 10, so that's 10. You're going to do these and bring them into class. Alright, almost done. Use polygon A, B, C, D, E, F, G, H to answer the problem 17 through 22. All the angles are congruent and all the sides are congruent. Naming of the vertices. Remember, vertices are points. So, and when we name a point, it's just the letter. So when we name all of the vertices, it's going to be A, comma, B, comma, C, comma, D, comma, E, comma, F, comma, G, and H. There's all the vertices. Naming of the angles. Now remember, an angle, we can use 1 letter or 3 letters. So, for example, angle A can also be named angle HAB. Angle B has another name. Angle B is ABC. Angle C here is angle BCD. Right, the next one, angle D. Angle D is going to be CDE. Angle E is going to be DEF. Angle F is going to be EFG. Alright. Now angle G is going to be FGH. Angle H here is going to be GHA. And then the next one is angle A, and we've already named it, so we've got them all. Now sides, remember, are segments, so you have to use segment notation. So I've got side AB with segment notation, BC, CD, DE, then I have EF, FG, GH, and HA. They're all my sides. Name the polygon according to the number of sides it has. Okay, I'm going to start here with this one. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided figure. An 8-sided figure, when I name it, it has a specific name. And so when it asks me to name it, I have to use the most specific name, which is octagon. You cannot call it, do not call it an 8-gon, because you will lose credit. You have to call it by its name, octagon. Is the polygon regular? Well, there's no indications here. There's no markings. But if you go back and you look, it says right here, all angles are congruent and all sides are congruent. So the answer here is yes, but it's because the information above the instructions states all sides and all angles are congruent. All right, number 22 we're going to do on the back. And number 22 says, the measure of the interior angle of a regular polygon is 157.5. Find the number of sides of the polygon. All right, so write on the back and flip your paper over. Okay, now, there's an easy way and a hard way to do this. I'm going to show you, this is just one method. There are several ways to do it. The measure of an interior angle plus the measure of an exterior. So remember that when you had a shape and you extended the side and drew it back, this was the exterior and this right here was the interior. And when you add an interior and an exterior together, it's 180 degrees because you're just extending the side, making the side longer. So that equals 180 degrees. Okay, so this is going to be 157.5 degrees was the measure of one interior. We don't know the exterior angle yet, so I'm going to put an E for exterior angle. But I know that when I add these two together, it equals 180 degrees. I'm going to subtract 157.5 from both sides. And when I do that, it's going to give me the measure of the one exterior angle. So the measure of an exterior angle. Okay, when I subtract that in my calculator, I get 22.5 degrees. All right, so now you know that that's just one of the angles. If you add them all up, if you know the measure of an exterior angle times the number of sides it has, it's going to equal 360 degrees. So I'm going to plug this in here, 22.5 times n equals 360 degrees. Remember, n stands for number of sides. So divide by 22.5, divide by 22.5. N is going to equal, when I plug that into my calculator, I get 16. So this is a 16-gon. And you're done. Now you can do that. You can use this and try to find all of the measures, the sum of this, and it's much harder to do, but this is just the shortest method for finding that. Okay, folks, that's the end of Chapter 8.1 notes. And make sure you go back and you show all of your work.